Folks, I'm showing about 2 o'clock, so let's go ahead and get started. First, good day to everyone. Welcome to Birding by Ear by Kelsey Lowe. Please mute and turn off the video of your device now. If you have questions during the presentation, please type them into chat. Kelsey Lowe is the Adult Programs Manager at Houston Arboretum and Nature Center. There she helps other adults connect to Houston's urban wilderness through classes on wildlife, native plants, art, cooking, and bird watching. She's been an avid bird watcher for nearly 25 years. She has a broad background in biology, studying everything from bird behavior to ethnobotany. As a committed advocate for nature in the city, she's a member of the Texas Parks and Wildlife Urban Outreach Advisory Committee, the City of Sugar Land Parks, Art, Recreation, Culture, and Streetscapes Board, and the Culligan Park Conservancy Board. Please welcome Kelsey Lowe.
Thank you so much. Thank you everyone for coming. I'm really excited about sharing with you today. I know some of you have already heard a version of this presentation, but I've changed a bit, so hopefully it won't be too boring. There is some interactivity. Don't panic, I'm not gonna pop quiz you, but if you would like to grab a piece of scratch paper and a pencil, I welcome you to do it. You have lots of time before we need it, but you can play along at home. If you have questions, please type them in the chat box, and I believe we'll have some moderators who can ask those questions interspersed throughout the presentation. I'm gonna have a break sort of in the middle so we can catch up with what you guys are asking. And don't be shy. I love questions. And if we run out of time, I can always get the organizers to email me the remaining questions and see if I can send you guys digitally responses, because it's way more fun than doing paperwork in my office, is answering questions about birds. All right, so let me get started. So birding by ear. This is a skill that I have been working on for my entire birding career, starting as a kid. But I didn't really work on it super strongly. I mean, I did it just you pick up bird sounds here and there as you go birding, but I really didn't work on it properly until I started working at the Arboretum 6 years ago, because the Arboretum, if you've ever been there, is very wooded. There's a lot of dense understory. There's a lot of invasive species, actually, but there's a lot of wooded area, and it's very dense, and it's very hard to see the birds at the Arboretum. It's not an easy place to bird watch. So you kind of have to listen to the birds in order to catch anything. And so at this point, about 90% of my birding at the Arboretum is by ear. So if I didn't try to identify birds by their sounds, I wouldn't notice as many when I'm walking around. And so it's a very, very useful skill. And it seems a little intimidating because there's 10,000 species of birds in the world, approximately. And each one has many, many, many different sounds that they can make. But I hope by the end of this presentation, you will feel a little less intimidated, even if you're not a birder, that you can start learning some of the birds around you, and then get not only a better way to identify birds and track them down, but beyond that, to kind of get a window into the world, to see what they're saying. Because it's really fun when you can hear them, you can sort of learn the meanings behind some of the sounds. We're going to talk a bit about that. And it just kind of brings a new perspective to the outdoors, which I think is really rewarding. So to hammer home my point, I'll let this be a rhetorical question. This is an image of the upper part of the ravine at the Houston Arboretum and Nature Center in a beautiful spring morning. Can you see any birds in this picture? I'm guessing the answer is no, because there aren't any. You can't see any in this shot. But if you were walking along this same environment, could you hear any birds? hopefully you guys heard that. And if you were, again, walking at the Arboretum, looking out over the edge of the ravine, you might not see a single bird in the morning. But if you sat and closed your eyes and listened, that was the sounds of 7 different species of birds. So you would have missed those 7 species if you hadn't been listening. So what I'm saying is, it's a lot easier to figure out birds if you listen rather than look, because birds don't want to be seen. Most birds have to worry constantly about who is looking at them. Now, birds do want to be noticed by other birds of their own kind. So let's imagine you're a male northern parula or parula, I never know which it is. You want to attract a sexy lady parula. So you could do like some birds do. You could do a little song and dance out in the middle of a clearing to be seen by all and sundry. But the problem is, if you make a big song and dance out in the open, everyone can see you. And if you're a small bird at risk of being eaten, you're going to get eaten if you can be seen. So what do? If you want to attract the ladies, but you don't want to be out in the open to be eaten by owls? Well, you sit up in the top of a pine tree, safely away from the predators, and you sing, which we'll be hearing soon, because these guys are one of the first spring warblers to show up. So Lady Parula hears the sound from a long way off, and she can get close safely and under her own time. And then under the cover of a shrub, they can do bird stuff. So what I'm saying is, there's a reason why it's much, much easier to hear birds than it is to see birds. And it's because they don't want to die. So it behooves us as naturalists to flow with their behaviors, to listen rather than always try to look for birds. So bird sound production is pretty fascinating. There are a lot of non-vocal sounds that birds can make. So non-vocal sounds include things like woodpeckers drumming, just literally hitting their beak on a tree trunk, or special feathers may be constructed in such a way that air blows through it and makes cool sounds. So those are non-vocal sounds. But today I'm focusing on vocal sounds. So birds use a very special organ called a syrinx to vocalize. So humor me again. Put your hand on your throat gently and hum or make some sort of sound. Go ah, and then stop. And you'll feel your vocal cords vibrating. So we as humans, we have vocal cords. So they're sort of string-like sets of muscles in our throats that vibrate when air passes over them. And we can control the tension of the cords just by controlling things in our throats. And so we create sounds rather like a violin string or a piano string, or even more like a reed instrument, like a clarinet, something like that. It's air flowing over strings and vibrating. That's not how birds work. Birds are very much different than us. So birds' voices are not in their throats. Birds' voices are down in their chests. So hopefully you can see birds have lungs like we do, paired lungs, and the lungs have a little tube. There's a tube at the top of each lung that meets in the center of the chest. But in the center of the chest, there's this little muscular 2-chambered organ called the syrinx. And so you'll see in the little animation on the right, there's the 2 tubes coming up from the lungs at the bottom. And when the tube meets the syrinx, there's a little muscular flap. It's basically a pair of lips. There's 2 pairs of lips in the syrinx, and the bird can control how open and closed the lips are and control the flow of air into the syrinx. So birds are more like flutes or more like wind instruments because they're controlling air moving through little holes in the system. Now, the cool thing is for birds, because their syrinx is 2-chambered and has 2 independently moving sides, they can do cool stuff like sing with one side of their syrinx while breathing in with the other side. So if you've ever heard a bird like a winter wren that sounds like it's singing forever and ever and ever without taking a breath, it is actually breathing. It's just only breathing with one side of its lungs at a time, which is a pretty neat trick. Some birds take it even beyond that, and they'll actually sing two separate notes at the same time because they can control those sides of their syrinx. So they can sing things that humans can't even begin to produce with our own voices because we just can't do that. Other times you'll hear birds make what seems to be an impossibly rapid series of notes, and that's because they're switching back and forth really quickly between the sides of their syrinx, kind of like you see slowed down in this animation. You'll see the blue side going, and then the pink side going, and then they can do it together. Now, not every bird can breathe while singing. Not every bird can sing two notes at once, but some of them can, which can lead to some pretty nifty sounds. Also, by the way, if you've ever heard like a parrot or some other bird mimicking a human voice, watch their beak closely when they're making those human sounds. You'll realize they're not making human words with lips and tongues because birds don't have lips, and bird tongues tend to be very inflexible. So all of those letter sounds are being made in their chest, which is really strange. And actually, my great apologies. I actually have a pet bird of my own. You might hear him chirping in the background, and he has decided he really needs to run over somewhere he's not supposed to be. So give me 1 second. All right, my apologies. He's decided that he really, really wants to eat my library books. Okay. Crisis averted. So what kind of sounds do birds make? Well, we talked about some non-vocal sounds like the woodpeckers drumming and air rushing through the feathers. But for vocal sounds, for sounds made by a bird's voice, they fall into two extremely broad categories: songs and calls. So what exactly is a bird song? Bird song, by our current accepted definition, which may change in the near future, but I'll get into that later. Bird songs are just used for courtship and territory defense. So here in North America, it's usually a male bird that defends territory and uses a song to explain his ownership of the territory. So he's talking to other males by singing, saying, I own this territory. But he's also advertising to females, hey, I'm single and ready to mingle. So in our case, bird songs are overwhelmingly male. That's not true in other parts of the world, but it is true here. And they're just for courtship and territory defense. So you hear them mostly in the spring, although you will hear them at different times of year. And bird songs, we tend as humans to sort of stereotype bird songs as melodic and beautiful and lovely. And so a good example would be the Carolina wren. Very simple, but beautiful. However, what defines a song is not how it sounds, but what it does. So if a bird makes a noise for courtship and territory defense, even if it sounds like this, that's a song. Remember that songbirds, which are the group of birds that does the most singing and sort of the most interesting singing, crows and jays and magpies and ravens are all songbirds. So songs don't have to be quote unquote beautiful. What they do is they're for courtship and territory defense. So what about calls? Calls are literally everything else. So songs have a very narrow definition. They're just used for courtship and territory defense. Bird calls are every other kind of communication that a bird can make, which, as they're rather noisy creatures, there's a lot of things that birds are saying. One of my favorite species around here is the Carolina wren. I hope some of you guys appreciate them too. They're so full of personality, feisty little creatures. One thing I like about them specifically is because they have a lot of different calls, and some of them are sex specific, which is kind of cool. Not every species of bird has that. So you can learn a lot about what's going on with your local Carolina wrens by listening to the calls. So we already heard a male Carolina wren singing in the last slide. We'll hear more about him later singing, but that's just a male thing. So males are the ones that sing for Carolina wrens. And so he does that to advertise courtship and territory defense. So this morning at 7 o'clock, I was awoken in my bedroom by a male Carolina wren singing on the fence outside my window because he has declared my backyard his territory, which is fine. I'm cool with that. But in the distance, his lady, his partner, might be making a very different sound, might be making a sound that sounds like this. I'm gonna play it one more time because it's worth hearing. It's this very, very high-pitched, rattly, buzzy sound. Oops. There we go. So when the male Carolina wren is singing, he's telling off other males. But interestingly, when birds are paired up, it tends to be that males fight with other males and females fight with other females. So that buzzy sound that we just heard, that's the female Carolina wren equivalent of a song. She's talking specifically to another female saying back off. So if you hear that sound, you'll often hear it with the male singing. And so you know the male is fighting with another male and the female is fighting with another female. Now you can also tell the difference between the sexes when they're just making sort of more normal calls. When they're trying to draw their partner's attention to something interesting that's happening, they'll use different sounds. So the female will use something called a dit. Whereas the male, in the same context, uses something called a beert or a cheer. And that's actually that sound, that sort of descending trill, that's a very, very common sound out in the woods. And it's one worth knowing because it's everywhere. But that there are some sounds that are shared between the sexes. And one of them is scolding. Now, my apologies, the sound is fairly soft, which is somewhat unusual because it's a very loud sound in nature, but this is the best recording I could get. Really buzzy. That's something called an alarm call. So that means danger. You'll often, if you're walking around near a wren nest, you'll get both parents come to you and do that. They'll make that scolding sound, or they'll make that scolding sound at a snake or a hawk or something that they think is dangerous. So that scolding sound is to warn other wrens of danger, but it's also directed at the predator or the scary thing to let the predator know that they've been spotted so that their chances of success are much lower and they might as well just go away. There's a whole class of bird calls called mobbing calls, where birds will start doing these mobbing calls at predators, and then those calls bring in other birds and they all start mobbing or attacking the predator and try to drive it away. That's a very good way to find predators like owls. One of the few ways I can actually find owls in the daytime is to listen for the mobbing calls of all the little birds that are attacking them. So how do we learn all these sounds? We just went through Carolina wrens and we didn't even do all the sounds that Carolina wrens make. And that was a lot of sounds and they all sound quite different. So how are we supposed to learn as humans all of these crazy sounds? So the classic way to do it, which is the way I learned it, and I don't knock it. It's a great system, but it has limitations. It's called mnemonics. Mnemonics is just writing down an approximation of what the sound resembles. So a classic one for the Carolina Wren song is tea kettle, tea kettle, tea kettle. Tea kettle, tea kettle, tea kettle, tea kettle. Easy to remember, sticks in your brain, it's excellent. Mnemonics are very, very useful for getting things stuck in your memory. But, that's a big but, they are limited. Because is the wren actually saying tea kettle? No, he's making bird noises. So mnemonics don't cover everything. So how about what happens when you read a competing field guide and see that Carolina wrens don't say tea kettle, they actually say Germany. Germany, Germany, Germany. Okay, so maybe they don't say tea kettle, maybe they say Germany. Well, then you read another field guide, and that field guide says they say chewy, 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 chewy. Which one do we believe? None of them, because the bird's not saying any of those things. Those mnemonics, don't be a prisoner to mnemonics, is what I'm saying. Those three sounds, tea kettle, Germany, 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 chewy, 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 those are all human written approximations of different sounds that a single individual male Carolina wren might make. So if they help you remember the sounds, great. That's fabulous. But that isn't what they're actually saying. And there's a lot of individual and regional variation in bird sounds. So don't let the mnemonics imprison you. Just because you hear something that doesn't sound like tea kettle doesn't mean it's not a Carolina wren. So here's where we get into the hard science. Spectrograms. Now, this is actually, apparently, this was an old way of learning bird sounds that fell out of favor in favor of mnemonics, but now it's coming back. And I am a full-hearted supporter of spectrograms. They take a little while to learn, but once you've learned them, it's the closest thing you're going to get to actually properly reading the bird sounds as they are, not filtered through human perception, because we have limited perception when it comes to bird sounds. It's actually a true depiction of what the bird says. So let's break it down. And don't panic. You're not going to learn all this after this talk. You're going to have to work on it if you're interested. And I'm going to give you some resources for that. But you can get the basics of it. It's very much like reading music. Along the y-axis, the up and down axis, you've got pitch. So the higher the note is, the higher it's going to be on the graph. And on the x-axis, the left to right axis, you've got time. So as time goes on, notes get further away from the y-axis. So very much like a piece of music written on a sheet. And so you'll see the different sounds that are produced. They'll be up and down in space, depending on what pitch they are. And they'll be further or closer to the start, depending on when they were sung. But they'll also be different lengths, depending on how long the note is held. So a longer bar indicates a longer note. And then there'll also be different shapes, depending on the tone of the sound. So it might look really fuzzy and buzzy on the screen if it is a fuzzy or buzzy note, or they might have different things that look special depending on the sound of the note. We're going to talk a little bit more about that in detail later with some examples. It's much easier to listen to it than to try to explain it. But let's get an example here. So this is a real spectrogram that I downloaded. So you'll notice it's very noisy. It's not as clean as the little sample spectrogram here, because this is just sort of a best case scenario in a soundproof, sound dampened room with just the one source of sound coming from it. This is a recording that was taken in nature. So there's a lot of background noise. So all that sort of grayish smudging in the background, that's all just air noise or bugs or traffic or whatever. And you'll notice that the pitches aren't perfectly clean. There's some noise around it, which is either an artifact of the recording or maybe due to the tone of the sound. But that same tea kettle, tea kettle, tea kettle song that the Carolina wren was giving, that's what it looks like in spectrogram form. So high, low, high, high, low, high, high, low, high, high, low, high. It takes a little while to practice your eye and get a sense of how these work, but once you do, it's not so bad. It helps to sort of break it down. So when you listen, imagine how you would draw it. High, low, high, high, low, high, high, low, high, high, low, high. So that would be an approximation of what you're hearing. But in reality, you'll see, because your human ear can't pick up some of the speedy stuff that's going on, the first note is actually rising in pitch. The second note is falling in pitch. And the third note is really falling in pitch, but it's doing it very, very, very quickly. But you can still see high, low, high, high, low, high, high, low, high, high, low, high. Once you've kind of messed with this system and you've learned how to practice drawing the sounds, like if you're out in the woods and you hear weird bird noise, you don't know what it is, you can draw jot down little notes, little dots or little slashes to say, okay, this is approximately what I heard. And you can take it back and try to figure out what it is later, rather than trying to just remember it, which never works for me. So here we're going to practice. We're going to practice. We're going to practice with a very relevant bird, a bird that's been singing quite a bit this spring. They're already nesting in my neck of the woods, Carolina chickadee. So yes, Carolina chickadees have songs. We're going to listen to a song from a male Carolina chickadee. If you have your piece of paper and pencil handy, feel free to try and draw the song. I'm going to play it a few different times. If you don't have paper, just try and think of it in your brain. So I'm going to play it a few times and see what you think. I'll play it again. All right, hopefully that's enough. When I draw the sound, it ends up looking something like this. High, low, high, low. In mnemonics, people call that Phoebe, Phoebe. And often when I'm drawing on the note on a piece of paper, because my notes tend to be fairly messy, I'll even indicate with arrows like down, up, down. Did your spectrogram look a little bit like this? I hope so. Just to give you an insight into a drawn in the field spectrogram versus an actual recorded spectrogram, here's what a real spectrogram actually looks like. So you'll notice that the first note, the high notes, are actually slurred high to low, but it happens so quickly, our human ears can't really parse it. So it just sounds like one high, low sound. But it's really not that different from your hand-drawn notes. It's just a little more detail. So like I'm saying, you're not going to pick this up overnight, but I find it a really powerful way of learning and depicting bird sounds because it just better reflects the reality of the noises that they're making. And it's kind of fun. So if that sounds too daunting for you, if drawing it on paper sounds like too much of a chore, congratulations, there's an app for that. If you have not already downloaded Merlin Bird ID from the Cornell Lab of Ornithology on your phone, you should do it. It's a really amazing tool. It's free. It's a great way to identify birds visually. So it will take you through, like, how big is the bird? Where did you see it? What is the beak shape like? What color is it? Blah, 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 blah. And it'll take you down to some likely candidates if you can see the bird, which is great. Great way to learn birding if you're new to birding. But recently, they have come up with Merlin Sound ID. So you can press the Sound ID button, point your phone at the bird, and if you're close enough, what will happen is it will start recording the bird and generating a spectrogram. So you can actually see the spectrogram of the bird that you're listening to, and then it will try to identify the sound based on the spectrogram. It's not perfect, but it's really, really good. And it really helps you get a sense of what might be around. And a lot of the times it's right. There's only been a few times when I've used it so far that it hasn't worked. Now, again, it has to be able to hear the bird, and it has to be able to hear the bird fairly clearly. So if you're really far away from the bird, or the bird's really soft, or there's a whole bunch of sounds happening at once, it's going to be less and less accurate. But if you're reasonably close to the bird, there's a really good chance you're going to get the right ID suggested. And even better, it'll let you save those recordings and spectrograms to mess with later, which is wonderful, because then you can go and compare it to stuff in your identification things that I'm going to share with you later. Or you can put them online, or you can like save them for notes and then see. You can compare unknown stuff to what you've already recorded. It's a really powerful system. And then every time you use it, you're actually helping to train the software. So you can report if it's made misidentifications, or if it just hasn't given you an option at all. All of that helps correct the system. It's very much like iNaturalist. If you guys are familiar with iNaturalist, when you use iNaturalist, take pictures of things and use the little automatic identifier feature, it's not perfect, but the more you use it, the better it's going to be, because you're kind of training it. So this is really good stuff, and I highly, highly recommend it. This is also very useful, by the way, if you're with a group. So you can record and then show everybody the sound. So even if not everyone can hear the sound, they can see it, which is really cool. It's also very helpful if you're hard of hearing, or if you're birding with someone who's hard of hearing, because even if you can't actually hear the sound, your software can. So you can see the birds calling around you, which is really, really cool. It's a very interesting way of expanding your ability to detect birds in the field. So, having said that, let's take a quick break and go through any questions you might have.
Okay, Kelsey, right now we don't have any questions. For everybody out there, if you have a question, please type it in the chat box.
I'll give everyone a minute to think about it, and if not, then we can move on. All right, well, I don't see anything furiously being typed into the chat box. In which case, we can move on. All right. All right. You didn't want a break? You don't get a break. We're going straight to the hard stuff. So get your pencil and paper ready, and we're going to do some practice. So the best way to learn bird sounds, bar none, is going out in the field and listening to birds. The second best way, which is a great supplemental way of learning birds, is to listen to birds on your apps or online. I'm going to talk a little bit about where to find the sounds if you want to keep practicing. But if you have a digital field guide on your phone or your computer, or if you go to a website that has lots of bird sounds, you can listen to as many bird sounds as you can. and then just be awashed in it. One of my favorite ways to learn bird sounds is to just pick a bird. Pick a bird that you see every day or a bird that you see really, really frequently. House sparrow, pigeon, starling, cardinal, whatever bird you see frequently. Just listen to that bird. Get to know the sounds they make really, really well. And you'll notice they make different sound in different scenarios, and different individuals may sound a little different, but you'll start getting a sense for that bird. Then once you kind of feel comfortable with that bird, congratulations, you've now learned a bird. And so every time you hear a different bird, you can say, well, it sounds like a cardinal, but, or it sounds quite a lot like a pigeon, but not quite. Then there's a good chance it's something related to a pigeon. If it sounds that much like a pigeon, you'll have a better way of comparing new sounds to the bird that you know. So then once you've got one bird under your belt, move on to the next most common bird that you see and start learning that bird, and then so on and so on and so on. The annoying and fun thing about birds is that you get such a different group of birds around you at different times of year. So in the spring, suddenly everybody's singing, and then you get all these migrants coming through. You don't hear it the rest of the year. And then they slowly subside. And then you get our sort of fall and winter migrants come in that you hadn't heard for the rest of the year. And then they slowly subside. So you'll get these sort of waves of, oh shoot, I forgot all the warbler sounds, and it's April. I need to learn my warblers again. You need to listen, you practice your ear with stuff that you hear online. And then, oh yeah, okay, I finally get the warblers down. By the time you finally got your warblers down, they'll be gone. But you'll be that much more ready for next year. It's an ongoing thing. And then sometimes you'll get surprises. Sometimes random individual birds will just do really weird stuff. And that's fun to notice. And it's really helpful to record it if you can. Because again, the more we have recordings that are shared in community science-based spaces like eBird or iNaturalist or the Merlin ID, the better it's going to be for everyone. So let's do some practice. I'm going to play some bird sounds. I'm going to play a bird sound. Don't tell me what it is yet. Just look at these three spectrograms, and figure out which of them do you think belongs to the bird sound. So you have A, B, and C choice for spectrogram. Which one do you think goes with this bird sound? All right. Hopefully either people are typing it in chat or maybe moderators can give me a sense. What letter does everyone think?
People are answering A. And I do have
A.
another question.
Oh, excellent. I will take the question before we get the answer.
Okay.
Increase the
Okay,
suspense.
the question was, what are the audio limitations of cell phone mics?
Oh, probably lots. I'm not a recording expert. That is a whole subfield of birding, by the way, is people who just do nothing but go around recording birds. There are limitations. Obviously, they're not that sensitive. You have to be quite close to the bird. They don't have much in the way of, say, wind protection or anything like that. So if there's ambient noise, it's going to get recorded. It's subject to human error, like putting your finger accidentally over the mic because they tend to be pretty small, or you're holding it the wrong way, or you're breathing heavily into it, which always happens to me. So there are definitely limitations, and they pick up a remarkable amount of information from the bird sounds, but they aren't quite as good as like a professional or hobbyist level actual, like a parabolic mic. So parabolic mic, if you're not familiar, is like, imagine the kind of microphone you would see in a sound recording booth, like a fuzzy covered cylinder microphone that you could hold in front of your face. It's like that, but it also has a big plastic satellite dish around it. So it's basically focusing the sound to the center with the mic and then picking it up. And those are well, they're not inexpensive, but they're a lot less expensive than they used to be. So if you're really into sounds, you might want to look for a good parabolic mic, and then a way to plug it into your phone or some other kind of recording device. Unfortunately, that's not something I do, so I couldn't give you any specifics, but the cell phone is enough to work for me as a fairly casual recorder.
Well, thank you. Okay, so most people answered A to your question, and there are a couple of B's.
All right. I'll play the sound one more time just for fun. All right, so we hear in mnemonics, in old school bird field guides, you will hear that sound described as J, J, or jeer, jeer. So it's sort of two notes, two iterations. So we know it's not C because this is a whole bunch of little short notes all squeezed in over barely 3 seconds. So it's not this guy. This would be this would be like a trill or a buzz. See, lots and lots and lots and lots of little short sounds. We know it's not B because B has quite a few little sounds, little notes, very quickly smushed together. So big, and then whew, whew. Interesting sort of slurred notes after a space. So we know it's not B because we can only hear two really big J, J. Although when you see the spectrogram, you will notice that it's not just two notes, what sounds kind of like two separate notes. To the human ear, the first one, obviously, they both fall. They start higher and they go down. J, J. Look how they're stacked. There's a whole bunch of pitches stacked on top of each other every time he says it. Looks a lot more complicated than it sounds. And that is because, so this is a blue jay, by the way. Then the answer was A. So good on everyone for getting A. Don't panic. I did choose B for a reason because it does look somewhat like it would be two separate notes. So I did that on purpose to trick you. But it is A. So you get these very complex stacks of sound. And what that means, it's very distinctive. It means that the sound has a very specific tone. So now we're starting to get into much more detail. And this is where I think it starts getting really fun, but your mileage may vary. When you see those lines all stacked vertically on top of each other, they're all the same, but there's a whole bunch. So obviously there's a whole bunch of different pitches. So starting low, but then going high. There's always the same distance in between them. Those are called harmonics. Those are called harmonics. And that's, physics is not my subject, so I start getting fuzzy on how this works. But remember that sounds are waves. They're pressure waves in the air. So they're just looking like an ocean wave. They're flowing, and there's big peaks, and then there's deep troughs. So the sound is flowing, rolling like a wave. But when you're sustaining a pitch, when you're making a sound, you can get sort of complex interactions between different waves of sound, so different pitches and things going on in your voice. And if you create a standing wave pattern, so instead of the sound just coming out, flowing, and the wave rolling away from the bird's mouth into the distance and sort of changing as the bird is singing, because it's singing different notes, that's normal sound. A standing wave is where when the bird is making different specific sounds, the waves sort of snap into a permanent form. So each wave is identical to the last, and they're just constantly making the same wave pattern. That's called a standing wave. That produces things called harmonics, which are important in human music. Don't ask me how that works. I'm not a musician, but you don't have to know any of that. The point is, when you see those stacked lines, stacked sets of vertical lines or horizontal lines in spectrogram, you get weird tones. It's weird sounds. They're not sort of classic straight sounds. So Nasal. A lot of harmonic sounds are nasal. So here's the blue jay again. Jay, jay. Like you're speaking with your nose, your nasal voice. Nasal sounds tend to be sort of whiny. Think about a kid that's tired and doesn't want to keep going on the nature hike. This is boring. I want to go home. Nasal things tend to sound very whiny. A lot of baby birds make nasal sounds. I don't know if you can hear in the background. My own personal bird is making a lot of nasal sounds. He's very annoyed. That nasal sound, that tone, comes from the harmonics. Comes from a whole bunch of stacked pitches forming a standing wave. So it's this really complex system behind what ends up being a rather simple sound. But it is quite distinctive. And when you see that pattern, you know you're dealing probably with a nasal sound. Now, there are other harmonic tones. One of them happening when a bird is singing two notes at once. So remember how we talked about when birds can use their syrinx, they can sometimes sing two separate notes at the same time. If birds do that, but then also create a standing wave using those two separate notes, instead of ending up with a nasal sound, you end up with something that sounds like no living organism could possibly make the noise. Sort of weird, ethereal, flute-like. Sometimes they almost sound mechanical in a way. If you guys are birders, you might have recognized that was a veery, which is a thrush. And thrushes are famous for having that harmonic, stacked, ethereal, flute-like tone to their sounds. So if you hear that ethereal, fluty, heavenly, it doesn't really sound like an organic being made that sound, there's a good chance here it's a thrush, because mostly thrushes here make that sort of noise. There are lots of other tones. A favorite one of humans is the whistled tone, which we already heard with the chickadee. Very clear, very pure, not a whole lot of extra buzz or fuzz on the spectrogram. They tend to be kind of straight lines. If you could easily mimic the bird sound by whistling, that's a whistled tone or a pure tone. Those tend to be the easiest bird sounds to learn, because if you can mimic it, it's much quicker to learn. Harsh tones are pretty straightforward. They are also called noisy tones because they are literally noisy visually as well as auditorially. You can see lots and lots of fuzz and buzz in the spectrograms because there's a lot of fuzz and buzz in the notes. There's other tones than this, but this is a good start. So whistled or pure tones are tones that are very clean looking on the spectrogram. They're easy to replicate by whistling. Harsh tones are very noisy. They're very buzzy. There's lots of mess on the spectrogram, and they tend to sound harsh or buzzy or mechanical. Nasal tones are those sort of whiny, blue jay, baby bird, blue-gray gnatcatcher kind of sounds that have those interesting harmonic stacks of lines. And then there's ethereal or flute-like tones that are also harmonic, but they sound much, much nicer than the nasal tones. The nasal tones tend to have an enormous number of harmonics all stacked on top of each other, whereas the more ethereal ones tend to have fewer. It's just part of what creates the differences in the sounds. It's really fun to go through and just close your eyes and listen to different birds and see how you would describe the tones. And even if it's something silly, if it reminds you of a really annoying third grader you took on a field trip, the whininess, great. That's going to help it stick in your brain. Or if it reminds you of a piece of music or your favorite instrument or a bug or whatever, great. Even if it seems silly and not bird related, it's going to help stick in your brain. It's going to help you remember it. So definitely go for those weird comparisons because that's a really good way to learn. All right. Spectrogram practice number 2. Again, I'm going to play a bird sound, and I would like you to pick A, B, or C. Which spectrogram do you think belongs to the sound? I'm going to play it one more time. I was actually hearing this bird yesterday when I was walking around my neighborhood, and that's why I picked it.
So Kelsey, B seems to be the popular answer. I do have an A, but B seems to be the one most people selected.
Excellent. All right, so let's break it down. So the last sound, the blue jay sound, I picked because it had a cool tone. This one also has a fun tone. It's kind of semi-whistled. There's some complexity going on there that we don't have to get into, but it's mostly a whistled sound. So it's going to be fairly clean on the spectrogram. What I really want to get at with this one is tempo. So we talked about tone in the last one. Now I want to talk about tempo. So listening to the sound, it's slow, quick, quick, quick. Slow, quick, quick, quick. Slow, quick, quick, quick. So looking at these 3 spectrograms, it's probably not this one because this is quick, 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 slow, 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 quick, 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 slow, slow, slow. This one is slow, 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 slow. This is actually a cardinal. C. Cheer, cheer, pretty, 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 pretty. Those of you who picked B, you are correct. That is a brown-headed cowbird. And it's this slow, quick, quick, quick. You'll notice what sounds like 3 sort of single notes is actually 3 very surprisingly complex slurred notes. They happen so quickly, it's really hard for our ears to detect that detail. But you don't have to. All you have to listen for is that tempo. Slow, quick, quick, quick. So I have a reasonably good ear for music. I can't read sheet music, but I did singing and stuff, choir and things in the past. So I'm reasonably comfortable with music. For people that aren't good with music, for people who have bad pitch or you're a lousy singer or whatever, great, that's fine. What I found is that folks who are less comfortable with human music tend to gravitate more to tempo with bird sounds, because if you have a hard time with pitch, which some people do, don't be sad if that's a problem you have. Focus on the tempo. Focus on the pattern of sound being produced more so than the pitch. Because that's really important information, and it may be easier for you to learn than trying to force yourself into pitches that are harder to understand. So don't think it's all about the notes, the pitch of the notes. It's also about the tempo. Quick, quick, quick. And like I said, for the cardinal, a very distinctive thing about the cardinal, because cardinal songs and Carolina Wren songs have pretty similar tones. And actually, if you just chopped off the rest of a cardinal song, I have a hard time telling the difference between some Carolina Wren songs and some cardinal songs. But cardinal songs do have generally a pretty distinctive tempo. It's that cheer, cheer, pretty, 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 or cheer, cheer, pew, 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 pew. Sort of a 2-part. There's 2 slower notes, and then there's a series of faster notes that come after that are quite predictable and they don't change very much. So knowing that tempo pattern can really help you make those identifications. And again, it just comes with practice. There's no substitute for going out and looking at a bird making a noise. For some reason, it seems to be a general truth that you can hear birds singing all day, and you will eventually learn. But the best way to actually learn the sound for a specific bird is to see the bird producing the sound with its face while you're out there, to just watch the bird singing, which is, it's a silly reason. Every picture I've had with a bird making noise, I've had that beak open, because it does seem to make a difference in how well we can learn those sounds. All right. Spectrogram practice number 3. Let's try hard mode. So this is intentionally very, very difficult. So please don't panic if you can't figure this one out. I have intentionally chosen 3 extremely similar spectrograms. So this is a challenge. So I'll play the song or the sound quite a few times. See if you can figure it out.
Kelsey, we have A's and B's and C's. It's hard for me to tell what we have the most of.
Well, I did do this on purpose. I'm going to play it a couple more times, and then I'm going to kind of go through. All right.
Maybe more B's, I think maybe.
All right. So that's fine. Having a spread is fine. This is getting into the really nitty gritty. This is next level stuff. So obviously, it's a lot of very rapid notes. It's a series of very, very rapid notes. In bird language, in bird sound language, I should say, that's called a trill. So this is a trill. It's a bunch of rapid notes all together. So we know it's going to be a rapid fire series, which each of these spectrograms has really quick series of notes. Now, let's get down to the details. With A, there's more gaps, there's greater time in between this first series than there is with the second series. And the second series, like, I don't think a human could even make notes this quickly. So it's tick, 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 tick. It would sound like a burst of radio static. Tick, 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 tick. If anyone has ever heard a ruddy duck do its display, you may or may not have heard it. It's tick, 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 but it's like this little burst of radio static at the end because it's just going so fast. This is a ruddy duck. So tick, 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 tick. So you can see there's a bigger gap between these first notes. So there's a longer period between these notes. Then there's a gap, and then there's a rapid fire burst. Not so in the sound that we're hearing. The sound that we're hearing, there isn't really, it's just kind of all the same speed. So it's not A. So A is actually a ruddy duck, but this isn't the ruddy duck that we're hearing. So what about B? So B is, again, there's a bigger distance between these first 3 notes and a much smaller distance between these next notes. So it's tick, 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 tick. And I can't possibly replicate this sound. I should have had these recordings. This is a marsh wren. Tick, 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 tick. It sounds like a machine, metal being sort of shaken. But there's these 3 separate notes at the beginning, tick, 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 and then tick, 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 tick. So there is a distinct difference in tempo there. And again, you don't get that separation in this guy. Just kind of a slight wavering around the same pitch and basically the same the whole time. So you can hear that. You can even see the pitch starts high and then it goes a little bit lower and then it goes a little bit higher at the end. but it's mostly hovering around the same pitch. Again, there's clearly harmonics happening because there's a bunch of stacked stuff. It's fairly noisy. It's fairly buzzy. It's a harsh sound. So this C is the correct spectrogram. There's a belted kingfisher. Not a songbird, but definitely a bird that still makes noise. And so all of this still applies. So don't panic. Don't panic if you picked the wrong one. Like I said, I intentionally picked very, very similar ones. But as you spend more time listening to birds in the wild, reading field guides, practicing with spectrograms in a variety of ways, the more of these subtleties you'll start picking up. And so that tempo, again, that tempo really, really helps. Hearing differences between the spacing of the notes at different times in the bird sound can really, really help you narrow down those identifications. So practice, practice, practice. The more you practice, the better you're going to be. And again, it can seem daunting because there's so many different species of birds and there's so many different sounds. But again, the nice thing is when you say go through the process I described before, you pick a bird. Let's say it's a wren. Let's say you got a Carolina wren in your backyard like I do. Just listen to that bird. Listen to all the different kinds of sounds it makes. Once you've got a good handle on the wren, you now have a vague idea of what all wrens sound like. Because even there are differences in between the species, there's a lot of things that are also shared. There's a lot of tones that are shared. There's some call types that are often shared among birds. Thrushes, for example, have that similar flute-like ethereal tone to their songs. Wrens tend to have really, really harsh, angry scold calls. So kind of once you've learned one wren, you've got a leg up on learning them all. And then once you've got a reasonable handle on the sort of shared stuff, then you know the genre, the musical genre of wren. You could hear a wren of an unfamiliar species. Maybe you could even hear a wren from South Africa or South America, a species that you've never encountered, but you'll hear the bird and you're like, well, I don't know what it is, but it sounds like a wren because it's got sound qualities in familiar with wrens that I know. It's just like music. You could hear a Willie Nelson song. You may not immediately recognize the song, but you'd be like, oh, it sounds like country. It's probably country music. Even though Willie, George, and Reba are very different artists, they're all falling generally under one umbrella. And once you've heard enough country music, you'd be like, okay, well, I don't know this song that's playing on the radio, but I can tell it's a country song because of the way it is, because of the tone, the subject matter, generally how it's produced. Like I get that this is what country music sounds like. It's the same thing with birds. Once you've got a sense of like your Carolina wren, you can start applying those qualities more broadly and you'll get a better sense of the genre of wren sounds. It just takes practice. We're familiar with human music because we're surrounded by it our whole lives. You're also surrounded with bird music your whole life. You just probably haven't sat down and analyzed it the way you've probably done that with human music. So it's not impossible. It's definitely doable. It just takes time and practice. So how do you do that? How do you identify the bird sounds? So Merlin, that app, strongly recommend downloading it on your phone. That's a really, really, really good way to do it. But if bird sounds really interest you, if you find this really fascinating, strongly recommend this book. It's called The Peterson Field Guide to Bird Sounds of Eastern North America. Doesn't roll off the tongue, but it is literally the book on bird sounds in our region. And if you're not a birder and you're wondering why Texas is considered Eastern North America, that's because for birds, everything east of the Rocky Mountains is east. So Texas falls in the Eastern category for field guides. So Peterson Field Guide to Bird Sounds of Eastern North America. It is a book of bird sounds. So obviously it's written, so they have to use visual depictions of sounds. Now, it does have an associated website that you can actually use for free, even if you don't have the book. So if you Google Peterson Field Guide to Bird Sounds of Eastern North America, you will find the accompanying website and you will find all of the spectrograms and sounds recorded online, which is extremely helpful. But having the accompanying book allows you to actually look up sounds. So if you're in the field and you hear, okay, I hear a trill, a rapid trill that's too fast, the notes are too fast to count. Okay, down here I see, okay, so it's a trill, it's repeated notes that are too fast to count. I'm going to flip to that section of the book and then go through the specifics and figure out which trill specifically I'm hearing. So you can actually look up the bird sounds in the book based on the spectrogram and the descriptions of the sounds, which is really cool. It takes a while to learn. It's not a book that you learn overnight. It's definitely a book that will take you a while to really get comfortable with, but I found it absolutely invaluable in the stuff that I've been doing I'm a professional naturalist, but as a hobbyist naturalist, if you spend a lot of time working with birds, bird sounds, that kind of thing, this book is very rewarding. The thing I like the most about it is, to the best of their knowledge, they indicate what contexts the sounds are used in. They don't go into huge amounts of detail, but they give you some sense for what some of the known context for different sounds. And that's what really gets me, because I'm really interested in bird behavior and what the birds are actually saying when they're making these noises. And so even though there's a lot that we don't know about bird sounds and what they mean, this book will be a really good jumping off point. So it'll break the sounds for each individual species into categories and say, like, okay, so these tend to be male sounds, these tend to be female sounds, this one is used as an alarm call, this one is the song. Some of them, they know even specifics. This is a begging call, or this is a sound that they use specifically in territorial interactions between females, that kind of thing. So it's really cool. And that'll give you a jumping off point if you want to learn more about the meanings of the sounds, of where you can look next to find out more about it. So I find it extremely, extremely useful. And it's been around long enough that you should probably be able to find it used if you don't want to buy it new. It may even be in your local library. If you want more practice, which I encourage you to do, I blatantly stole the format of my spectrogram practice from Cornell Lab of Ornithology. They have a website called Bird Song Hero. Bird Song Hero. If you're familiar with the old video game Guitar Hero, it's a riff on that. So Bird Song Hero, you can go online to the Cornell Lab. It's all age friendly. I've checked. It's actually designed for school kids, but anyone can use it. You will hear a song or a sound from a bird, and then you have to pick between 3 spectrograms to see which one you think is the right one. And it will give you 10, a series of 10, and then you get a score out of 10. And then when you play it again, it'll be a different set of sounds. I'm not sure exactly how many sounds. They probably won't be endless, but they have a pretty good library of sounds to draw from, literally. Another good resource that the Cornell Lab has is something called the Macaulay Sound Library. So the Macaulay Sound Library, if you Google Cornell Lab Sound Library, it'll come up. So the Sound Library is a massive database of sounds, animal sounds, not just bird sounds, but whales and apes and insects and all kinds of things that you can listen to. And there's also videos, so you can actually see the critter making noises or doing something fun. And they are linked to this Birdsong Hero. So the Macaulay Sound Library is an amazing tool. The only problem with the Macaulay Sound Library, which is admittedly only a very small problem, is that it is copyright protected, which is fair enough. People have worked very hard to record those beautiful sounds. Cornell Lab has worked very hard to categorize and make sure that they're properly identified and they're in usable packages. You can ask permission. They have a set process for you asking permission to use the sounds, but that does take some time, and sometimes it does cost money, which is, again, completely fair, but it is a barrier. Now, if you're like me and you make a lot of presentations or play a lot of bird sounds and things on your phone, I don't got time for that, nor do I have the budget for that, to be completely honest. So I love the Macaulay Library, but I tend to not to use it. What I use instead is Xenocanto. Xenocanto, Xeno-Canto. This is a database of publicly submitted sounds. So anyone with a phone or a microphone can upload bird noises. It's just birds, unfortunately, although you do sometimes get insects and things in the background. And they are all available for free for anyone to download with credit, of course. So every bird sound that you just heard in my presentation is all from Xenocanto. I use this website constantly because I can be like, oh man, that was a weird sound cardinal. Was that really a cardinal out there? And then I go to Xenocanto and I go into search recordings and I type northern cardinal. I click on northern cardinal, and then it will have hundreds of recordings of cardinals. And it'll not even then, it'll show me where those recordings were made on a map. So I can see, oh, let's listen to a cardinal from New York State. I'll listen to a cardinal from New York State. Okay, now I'm going to listen to a cardinal from the Florida Keys. You can listen to a cardinal from Florida Keys. I'm going to listen to a cardinal from Arizona. Listen to a cardinal from Arizona. And you can get a sense of regional variation, individual variation, seasonal variation, sex variation. Now, not all the recordings are fabulous because it's just random people. There's often noises and stuff in the background. Sometimes they're misidentified, though they're actually really good about that. So I would feel very confident unless it's a very newly uploaded sound. Even better than having all of those sounds available for free to mess with. You can download not only the song, but you can download the spectrogram. So again, the reason I had all those spectrograms associated with the bird sounds is because I could download them for free from Xenocanto. So I'm obviously a very firm believer in Xenocanto. I love freely available nature and science related tools. I think it's absolutely brilliant and something we're supporting. So if you want to go check out Xenocanto, check it out. If you've made some bird recordings, I encourage you to upload them because every bit counts. And they even have recordings of some really, really rare species from all over the world. It's not just US birds, it's birds from everywhere. So you can take sort of a global bird tour, which is really cool and definitely fun to explore as long as you're not sitting in a cubicle with a bunch of office mates. But my coworkers are used to it by now. I make a lot of noise at the Arboretum in the office. So I have actually some extra slides if we're interested and we have time, but I did want to pause again for questions.
We have one question, Kelsey.
All right.
If you could go over the distinction between a bird's song and its call again, please.
Yes.
Because some guides categorize them the same way.
Yeah, okay. So this is actually a great time to go into the messy nature of reality, because reality is never as clean as how we categorize things, which you guys should probably know as naturalists, but it's worth explicitly talking about it. So the currently accepted dry definition of a bird's song is a vocalization used for courtship and territory defense. So a male great-tailed grackle in a Walmart parking lot making this sound. If he is sitting on a tree, broadcasting that he owns this tree, that this would be a great place for the ladies to nest, but it's his, no other male can have this tree, that's a song. It could be very simple. A lot of flycatcher songs are just like a note. And they're very stereotyped and they barely even sound like a bird sound, but they are songs because they are used for courtship and territory defense. That's called a song. Bird calls are literally every other kind of vocalization a bird could make. So calls that are used for general communication between birds. So a bird that's begging for food from its mom, that's a call. A bird that's just kind of constantly doing something called a contact call, just a quick little noise to say, hey, honey, are you still alive? Yes, I'm still alive. Are you still alive? Yeah, I'm still alive. So sort of these little contact calls to keep pairs or flocks or parents and offspring sort of coordinated and together in space. Calls that are used even in some territorial interactions, like the female wren call, that chatter that female wrens use when fighting other female wrens. That's considered a call by current definitions. Not a song because it's not used for both courtship and territory defense. It's just used for territory defense. Same with the scolding. It is used for defense, a scold call or an alarm call. It's used for sort of defending the bird family against everybody else, but it's not a courtship thing. It's just a warning or a danger signal. Calls can be very specific. There are some birds that are relatively well studied in other parts of the world where they have calls that are specific to different kinds of predators. So fairy wrens, for example, in Australia and New Zealand, they have specific calls for aerial predators like hawks, and they have specific calls for terrestrial predators like snakes. And then they have sort of more general multi-purpose alarm calls. So they can get really detailed. There's all different kinds of things that birds could call about. But they're used for all kinds of things. So those are calls versus the courtship and territory defense is just the song. Now, having said that, you can probably tell that there's some wiggle room. Like the difference between the song of a male Carolina wren and the chatter of a female Carolina wren is pretty thin for the purposes that it's used for. And it turns out that there may be, okay, there may be some sexism involved in these arbitrary definitions. That may not be fair, but because a lot of the science terms for describing birds have been generated in places that just happen to have both male-dominated science and male birds that do most of the singing, we kind of codified these terms, the differences between songs and calls, before we, the science community at large, realized that birds do very different things in other parts of the world. For example, in Australia, pretty much all male and female birds sing. And actually, they almost always sing as a duet. They sing together. That's kind of a thing. So it isn't as clear cut in other parts of the world. And then it turns out that scientists were saying, well, okay, so maybe we're going to need to start broadening the definition of songs, but maybe what a song is this is one stereotype thing with each species. Species got one song, and then everything else is a call, and that's it. It turns out that there may be multiple things that could be called songs within a species. Actually, where is my Carolina chickadee? This guy, Carolina chickadee, I played you. This is considered a song because it's used for courtship and territory defense. But it turns out there's another vocalization that they make called a gargle that I didn't include here. It's a very strange little liquidy, almost metallic gurgly noise. It doesn't really sound very exciting from a human perspective, but it is used in a very similar way to what we would consider this classic song. And so maybe they have two different songs. Maybe we're trying to artificially shove a very broad spectrum of vocalizations into categories that are too narrow. We don't know. So watch this space. What is a bird song and what is a bird call? Those definitions may change in the future. But for now, as far as I know, what you're going to see in field guides and stuff is songs are for courtship and territory defense. And in North America, it's usually a male bird that sings. And then calls are literally every other kind of vocalization. So that is my long-winded difference.
That was a great answer. Thank you. I don't see any other questions, but this has been absolutely fascinating.
Excellent. I'm going to throw in, because I have some time, haha. You thought you were rid of me. Just because they're cool and I have them, So way back when we were talking about bird sounds being vocal or non-vocal, there's some really cool local non-vocal bird sounds that you might look for that are really neat to think about, especially if you're working with kids, but adults appreciate them too. Woodpeckers. So I'm sure that most of you have heard woodpeckers drumming. So that is a woodpecker of either sex, male or female, very distinctly and rapidly hitting its face against a tree or your aluminum siding or a metal telephone pole, something that will cause a nice reverberating sound to echo through the area. Woodpeckers are not songbirds, so they don't have a vocal song, but drumming is used for exactly the same purpose that songs are. Drumming is used for courtship and territory defense. So woodpecker songs are actually their drumming. So they're non-vocal, which is really cool. And both male and female woodpeckers will drum, although male woodpeckers do tend to drum more. Also, with a practiced ear, you can tell the difference between species of woodpeckers based on the pattern of their drumming. Although you will get some annoying ones, like this little downy woodpecker. They're very small. So usually their drumming is pretty soft as far as things go. But I did once experience what I thought was the loudest woodpecker noise in the universe. I thought surely it must be a pileated woodpecker, the really, really big guys. But it turned out to just be a little male downy woodpecker who had picked the perfect hollow tree. And it just amplified his drumming to just echo through the woods. It was amazing. It was a very lucky woodpecker. That's a great example of a non-vocal sound. And then there's another one. This isn't the world's best recording, but it's the best one that I could find. When ruby-throated hummingbirds do a little display, so the male will hover in front of the female and he'll wiggle back and forth and he opens his tail. So you can see in the photo, he's got these really weird skinny tail feathers that are extra skinny at the tips. And then they broaden toward the base, especially those two outer tail feathers are quite distinctly skinny at the tip. And he flares that tail out and wiggles side to side to side to side to side in front of the female very rapidly. And it sounds like this. I don't know if you can hear that sort of whining sound. That whining sound, not the buzz of his wings, but that whining sound, that's not his voice, that's his tail. That's air rushing through the feathers in his tail, making this whiny sound or whistly sound. And that's common to all of our hummingbirds here in North America. The males all have very different tail feathers than the females do. It's quite striking. Next time you look at pictures of hummingbirds, males and females have completely different tails. And it's because male hummingbird tails are modified to make sounds when air rushes through them. So all of our hummingbirds, the male courtship display involves them either diving at high speed with air rushing through their tails or wiggling side to side with air rushing through their tails to make very distinctive and very species-specific non-vocal sounds, which is very cool. You don't get to hear a ton of hummingbird courtship in our area, but we do get to hear a little bit, and it's worth listening for because it's a neat example of a non-vocal sound. And then finally, just to add another curveball, you've got mimics. What do you do if you're trying to learn bird noises and the bird is making another bird's noise? How are you supposed to learn that? Well, there's two ways to do it. And I use these two birds as an example. So everyone here in Texas should know the northern mockingbird. It is not only one of our more common birds, it's also our state bird. Hooray. And they are noted mimics. They're named after their ability to mimic, and they are very, very good mimics. They will mimic other bird sounds so well that you can't tell the difference between the mimic and the original. So what is a birder to do when they hear a white-eyed vireo a random noise, and then a great crested flycatcher in rapid succession. Well, the answer is you just heard a bunch of random things in random succession. Mockingbirds are very helpful for us humans in that they don't just mimic one sound and then stop. They tend to mimic a sound 3 or 4 times and then move on to another one and do that 3 or 4 times. And then they move on to another one and do that 3 or 4 times. So they'll do vireo, 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 frog, 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 car alarm, car alarm, car alarm, great crested flycatcher, great crested flycatcher, great crested flycatcher. And then maybe they'll cycle back around. But if you hear a purple mark, there's a mockingbird that lives at the Arboretum in the savannah. And it fools me every ding dang time. I walk through the savannah, I hear purple martin. And I'm like, oh, it's a martin. I get really excited. And then I hear a martin again. And then I hear a martin again. And then I hear 3 other things. Like, dang it, it's the stupid mockingbird again. So if you hear the same bird sound 3 times in succession, and then you hear something else 3 times in succession, and then you hear something else 3 times in succession, you're dealing with a mockingbird. Brown thrashers and gray catbirds also do it, but they repeat different numbers of times. But it's the context of the sound that tells you that, oh, I'm dealing with a mimic. Now for blue jays, I don't know how much time you guys have spent hanging out with blue jays, but I have spent a lot of quality time being yelled at by blue jays. And blue jays are incredible mimics of birds of prey. They can make absolutely perfect bird of prey sounds. I've heard them do red-tailed hawks. I've heard them do Cooper's hawks, merlins, kestrels, red-shouldered hawks, and even in the case of this individual, oh, I lied. I thought I had used a different recording. Well, this guy's doing a very weak red-tailed hawk. I need to switch that the next time I do this presentation. I have a recording of a blue jay mimicking a bald eagle, which is very impressive. How do you tell the difference between a blue jay and a hawk? You have to find it. Really, there's not another way to do it. I am constantly fooled by blue jays. Their mimicry is exceptionally good. And they actually give the calls of birds of prey the same way that birds of prey would. They do it with the same kind of timing. So it's really, really challenging to figure out the differences. The best cues that I know are if the bird of prey sound is coming from a very small twig or from deep in a bush lower to the ground, it's probably a blue jay. Because a bald eagle's not going to fit in a tiny shrub next to your feet. Another helpful thing is that often they'll do other blue jay noises. So you'll hear this perfect red-tailed hawk and you'll be like, oh, it's a hawk. And then you get up closer and then suddenly you start hearing jay, jay. And you're like, oh, it's a blue jay. So you have to kind of sit and figure out where the sound is coming from if you're going to figure out blue jay mimicry. But yes, endless fun with bird. Go on all day. But I think I will stop now before I get too entrenched.
Kelsey, this is Mike. That was an absolutely fascinating and challenging presentation that we all greatly enjoyed. We certainly appreciate you spending your afternoon with us. Can't thank you enough. Just great.
You're welcome.
And I'm seeing comments in chat. I'm sure this was absolutely well received from our entire group.
Excellent. Thank you guys so much for having me. If you have any questions, feel free to reach out to me. I'm at the stuff. Come say hello.
Okay. Hope to see you at the Arboretum someday.
Excellent. You're all invited.
Thank you.
All right.